Welcome to Ethical Hacking Essentials, Module 11, where we're going to talk about cloud computing, threats, and countermeasures. Let's have a look. In this module, we're going to look at multiple items. Number one, we're going to look at cloud concepts, container technology. We're going to look at threats against cloud computing, attacks and tools, countermeasures for cloud computing and cloud attacks, and we're going to look at an overview of some of the security tools that are available for the cloud. We're going to start with the first section, understanding cloud computing concepts. Now, for cloud computing, it gives us so many capabilities. On-demand services, distributed storage, rapid elasticity, automated management, broad network access, resource pooling, measured services, and virtualization. What does all that mean? Well, for instance, for on-demand service, let's say that I need to have a computer with 64 gigs of RAM and 16 processors and several other requirements. I put a check in a few boxes and there I have it, on demand, no prob. Whereas before, if I needed that type of computer, I'd have to get my requirements and then go online or make a phone call to Dell or HP or some other type of server vendor and then wait several weeks for it to be constructed and delivered. So this is on demand. It's distributed irrespective of where you are in the world. There are different zones that make it possible. There's rapid elasticity. If I have an app, for instance, where I sell a huge amount of services, but mainly during the Christmas season, right? From around Black Friday all the way through January 1st. And then after that, my sales don't really go very far, right? So mainly I'm selling stuff during that season. If that's the case, then I'm going to need more capabilities during that season. And so with the cloud, I can rapidly expand to more services, more servers, more workload, whatever it is that's required for my services. And then after January 1st, I can spin that down and go back to a smaller footprint, pay less money on a per month basis. So I can use rapid elasticity and I can automate a lot of the tasks in the cloud. There are so many resources to help with that automated cloud resource idea. Also, I have resources that can be pulled and from many different locations. I can stripe my resources across data centers. The service can be measured and managed. And it's all really built on and makes use of and makes available virtualization. So the cloud is pretty amazing. And it really isn't just Dropbox or Gmail or some other type of use like that, but it is truly the myriad of services that are provided to us by providers like Google Cloud, AWS, and Azure. So these are literally hundreds of services that you can find in these locations. So some of the many services you can find is infrastructure as a service. So let's say I need that 64 gigabyte RAM, 16 processor computer. Well, I just go to EC2 or go to Rackspace or go to Azure and I can pull the entire computer together, or I just might need some infrastructure like storage. I can go to OneDrive or you get an S3 bucket on AWS or whatever, right? These are infrastructure level things. These are things that would have required hardware before the cloud. So think of it like that for infrastructure as a service. For platform as a service, I have a developer. The developer needs IIS as their web server or Apache as their web server, or I need to spin up Salesforce for my team or whatever. It's a platform. It's ready for me to develop, for me to write code on top of that platform. And that is PaaS, or platform as a service. Well, what about software as a service? Have you ever used Google Docs or Calendar or Salesforce CRM or FreshBooks or any type of web-based application, Gmail, Outlook, Hotmail, and literally tens of thousands, hundreds of thousands of other software that you can get as a service. But wait, there's more. There's identity as a service. Let's say that your team puts together an application, and in the application review, it is found that your app is hackable, because all someone has to do is export the hashes of your stored password information. And so your team says, you know what? We need robust, modern identity services that we can use on this application. Now, if we were developing this app on premises and we had a physical server running Apache and we developed the web app on Apache, and I also had this system running with Microsoft, with a Microsoft network running Active Directory, I could integrate Active Directory with those Linux systems and then leverage the Active Directory integration into the Apache services in order to provide identity services. But in this case, I have a single sign-on, multi-factor authentication with one login, Okta, Azure Active Directory, Centrify Identity Services. I just plug it into my app. There's an API for that. But then I also have a container as a service. So I need a container. I just get it. I mean, go to Amazon AWS EC2, or if I need to manage and orchestrate my container, to go to Google. There it is. I found the word. Google Kubernetes, or that Google Kubernetes engine, which is the GKE, and I have a container. If I need security as a service, so I need pen testing, authentication. Let's say I need to have IDS or an IPS, intrusion detection or prevention system. It's in the cloud, in Switch Fast Technologies, or in One Neck IT Solutions, or McAfee Managed Security Services. I plug it in to my environment, plug it into my app, and I have security as a service. Also, there is, like, for instance, Azure and other SIMs, and that interface also with on-premise security. So very cool stuff. Function as a service. This is otherwise called serverless computing. Let's talk about how that works. So let's say that I've written an app. It's 2 million lines of code, and a big chunk of that is dedicated to calculating a certain function that calculates a whole bunch of stuff and then outputs some type of stuff, right? We're using the word stuff there in two areas, but I don't know what it does. But all I know is every time we get input into that function in the program, the CPU levels spike and the memory goes up, and it takes our computing system a long time to process that information, and then it spits it into the rest of the program, and other modules take that result and use it for other purposes. Well, what if I don't want to take all of that computing time to compute that chunk of data in that function? Well, I take that function and I move it to the cloud, and I move it to AWS Lambda, Google Cloud Functions, Azure Functions, or Google Cloud, Oracle Cloud Functions, and just have those massively cool computers do the calculation themselves. And therefore, now I have my app, my program, with all of its code, and it gets to where it needs to make a call to that super calculating function. Instead, it goes and calls that function in Lambda or in Azure Functions. And then a spike in computing power comes back without taxing my computer at all. And then the answer, it could take a lot less time. And so that is a function as a service. So there are many other services. If you can imagine a service that can be provided by on-premise data center computing, you can get it in the cloud. One area that's extremely important to work out, understand, and be ready to work with is the fact that responsibilities are different in the cloud and with the cloud and with your cloud provider than they are on premises. On premises, on my own data center, my own apps, my own platform, I am responsible for everything. But in the cloud, I split that responsibility between me, the subscriber, and the service provider. And here is the reason why this is important. Let's say that I'm running platform as a service, and I tell my cloud provider, look, I have a problem with the data. What did you guys do with it? Why is it so messed up? Or whatever the problem is. And they tell me, I'm responsible for the runtime, you're responsible for the data, and we go back and forth, and I want to sue them and everything because I did not understand the separation of responsibilities. So when you have a major engagement with a cloud service provider, make sure you read your contract and make sure you understand that with each level of service, and in some cases with each provider, there's a different level of responsibility, and make sure you understand that at the service level agreement and the contractual level. There are also different cloud deployment models. One of them is the public cloud. And when we're talking about Azure and AWS and services that are open for anybody to use, if you pay a small phenomenal fee, unless you're using AWS free tier, and same thing in Azure, you have all these users that are working through the cloud provider. Down here we have users that access the cloud within the security perimeter, and if you want, you can get extra security, optionally subscriber controlled security, etc. So we have this border controller giving you access to the cloud provider. It's a public cloud open for anybody to use. The other type of cloud is a private cloud. And so let's imagine this. Let's imagine that you have a corporation. This corporation writes an app. This app needs to be used by everybody in the entire organization. This organization has 5 different locations across the country. Each of the locations has more than 1,000 employees. And when the dev team has written the app in the past, and there's a new version of the app, what they do is they use automated tools to uninstall the old version and reinstall the new version on every workstation and desktop. And in doing so, periodically there'll be 1 or 2 workstations or desktops that don't respond to the call to do the uninstall and the reinstall. So in the 5 different locations, you'll have IT staff that have to go to the desktops that were missed somehow and do a manual restall or a restart of the desktop. And eventually, perhaps after several days of working on the app update, every one of your desktops is updated for this app for your employees to use. Now, in the process of doing so, we made use of scores of IT personnel. We had people who couldn't use the app because of an incomplete install or lack of install. And we took a whole lot of the resources and time of the organization that, if we were to measure it, could be in the tens of thousands of dollars. So let's say instead of spending tens of thousands of dollars on the quarterly updates of that app, we spend some time and money putting together a cloud computing infrastructure. What does that mean? That means that at each of these locations, we have a automation and virtualization set up so that our applications can be delivered through web services to the desktops. And so that anytime I have an update to the app, all you have to do is refresh the browser and you have an update to the app. And so we put together our own private cloud for the delivery of services like that application. Each location synchronizes with the other through the wide area networking links, and the application gets updated whenever I need. And I no longer am spending tens or hundreds of thousands of dollars just because I need to do common and often updates. And instead, it's all maintained centrally, and it frees my IT teams all over the organization to do more important tasks. So private cloud can be very helpful, but there is a large initial expense and then ongoing expense for maintenance in getting this up and running. But I've worked with private clouds. They're actually very interesting, and they really help to provide that organization at the dev level with a lot of flexibility. We also have community clouds. With community clouds, we might have some types of people. Let's say that there is a meeting of the National Woodworkers Association. And with the National Woodworkers Association, you have independent woodworkers, unionized woodworkers, woodworkers in small shops, large shops, and industrial woodworkers that all use similar applications, similar resources, but they're doing it in hundreds of different ways that it overall is costing the woodworking community a lot of wasted time and effort. And so they decide, hey, let's go ahead and go together on putting together our own cloud. And so they make a community cloud. And it's only for those organizations that subscribe to it and that are in the same business. And you'll have applications that are made specifically for that those services, whether it be having to do with other concerns like jurisdiction or compliance or security, or whether it's just really having to do with the type of work that the organization does. So they can work together, collaborate, and get their own cloud. Now, sometimes we have these combined. Like for instance, you may have your own private cloud. And let's say the private cloud is just for the delivery of a couple of apps that your organization has, and you want to cut down on the overall costs of maintaining that app. But you also have assets in public cloud, and maybe you have other types put together. And if you're using a combination of any of these, then it is a hybrid cloud. There's also the idea of multi-cloud, where you heterogeneously combine workloads across multiple vendors. So I have a lot of work going on in Azure, plus some more work going on in Google and Amazon and other locations. And you have to pull that together and manage it. It can be a daunting task when you're doing heterogeneous multi-cloud. Another idea to take a look at, and that would be the idea of the NIST Cloud Deployment Reference Architecture. This is good to take a look at because it helps to define some of the basic terminology of cloud computing, including who is the cloud consumer. That would be somebody like you or me, somebody who works for a company, the company itself, the organization that is actually making use of the computing services. Who is the cloud provider that gives us the SaaS and PaaS and IaaS and everything AAS? That would be the provider. They're the organization that allows consumers to have access to all these resources and services. Who's the cloud carrier? Well, there could be an intermediary that helps with providing connectivity to all these cloud resources. What about the cloud auditor? The cloud auditor is going to take a look at everything that's going on, making an independent assessment of all of the cloud service controls. Remember, we talked about a control. It's any physical or logical construct that mediates an entity's access to resources. That's the Kevin King definition of a control. So we have, whenever you think of Control, Alt, Delete. Logging in, right? That is something that keeps me from accessing my resources until I get past that Control, Alt, Delete. That's what I always think of with security control. And then we have a cloud broker who's going to manage the cloud services, help aggregate them, help us with maintaining those relationships, that arbitrage between all of these other factors. Now, you can go to the NIST, and it has a little bit more information on this. All right, so what is the cloud storage architecture? With the cloud storage architecture, we have several things going on. Now, often when somebody thinks of cloud storage, we think of something like Dropbox or Box, I think is another one. These are places where you can get multiple terabytes of storage and create folder hierarchies and store items in that hierarchy. But with the cloud storage architecture, it is a lot more complicated than that. For instance, if I write an app and I need access to storage for an application, that's one way to do it. If I'm collecting video or audio information through that app, and I need to separate that storage into different stores, that's another one. If I create a virtual machine and I need to attach storage as a D drive or an E drive or a C drive, that's another application for storage. So in the end, what we end up having to do to make storage work is to provide, first of all, high-level APIs. These are application programming interfaces that our dev team, our programmers, can use. And they can make use then of the middleware, all the virtual computer servers. These are virtual servers that access cloud storage objects, make use of storage pools. But all of that is the middleware, because at the back end, this is where the actual hardware is, the storage area networks, the petabytes of storage that the cloud provider has at multiple locations around the planet. There are even cloud storage locations and cloud server locations under the ocean and in orbit. And it's only going to be more so that way as time goes on. It's crazy the amount of locations that we have cloud architecture. But anyway, that's the storage architecture. And we are also going to take a quick look at some of the providers. And you might want to open up a tab and check these out. And also, I would recommend that, especially with AWS and Azure, that you create an account. AWS has a free tier. Make sure that you watch a YouTube video or go to an internet resource that talks about how to make use of free services in Azure and AWS, because you don't want to end up getting charged if you're just learning how to use it. So I would recommend making an account in Azure and AWS. Only make sure you monitor and carefully make sure you stay out of services that'll cost you any money. There's the Google Cloud. IBM makes a great cloud. In terms of signing up for services, one of the services that I would recommend that you do for IBM is their quantum computing services. They'll teach you quantum computing. You can make an account and step-by-step submit workloads to a quantum computer, which is actually pretty cool. So each of these providers, and there are many other providers that do a lot of services that are either very inexpensive or free, that you can learn to use so that you can be really good with the cloud. Okay, so let's now have a discussion about container technology. Containers have taken application delivery by storm, because what you can do with a container is you can take the application itself without an operating system, provide that application with only the dependencies that are needed, and get that application delivered. If you've ever gone to Outlook.com and used your MSN account, your Hotmail account, or your Outlook account, or you've gone to Gmail and used your Gmail account, or many of the most popular web apps, Facebook and other social media, are delivered through containers. And so what we have here is we have a developer that can put together and accredit the images for a container. And then what happens is we have a whole section where we, under the container technology architecture, we can store it. There's a registry, both internally and externally, depending on how the container and when the container is going to be used. And then we have an orchestrator. Whenever you think of orchestrator, I think we've talked about this before, but just in case we haven't, think of an orchestra. In an orchestra, we have heterogeneous sounds. We have bassoons and violins and percussion. These are all very different. But we have a director that brings them all together, and sheets of music that really help with that too. But we take all of these different instruments and make them sound as one. And that's what an orchestrator does. I have all of these heterogeneous structures, in this case, in my container world, that all require different resources, need to go to different places, need update processes at different times. And I need something to help automate all those processes for my containers. And that is what the orchestrator does. So we have admins that work with the registry and with the orchestration, and Kubernetes is one of the big orchestrators that we see working with containers. And then in the end, we deliver those containers. And those containers, what it looks like when you're using an application that is really a container image, it just looks like an application that's running in your browser. That's it, very easy for the user to access and use. So what we see is an evolution. The evolution started out in crowded data centers with data center managers purchasing servers that had lots of memory and lots of storage and lots of CPU capacity, but hardly any of that capacity was being used because it was running as a DHCP server or a DNS server, or maybe there was one app running on it and maybe 3 to 4% of the capacity of that server was used. You stripe that across a large data center and you have a huge amount of capacity that is not being used. So enter hypervisors, virtualization, where I could take that server that only 3% of it was in use, and I can run 4, 5, 6 virtual servers, virtual hosts, virtual guests, on that host. And now I'm using 70, 80% of that system. And what that ended up doing was shrinking data centers by around 90%. It's crazy how much data centers receded and the amount of real estate that they took up, which really lowered prices and made things more flexible because I could deliver services like we were talking about before. Infrastructure as a service came out of that. But now, if you imagine this, I have a virtual machine that we see right over here on the left. Right on the left here, we have a virtual machine. And as we see, we have an entire operating system. It could be Windows Server 2022, or it could be a Windows host of some other type, or Ubuntu, or even a Unix or something else. And let's say that it's dedicated to a specific app. Now, what happens is there are so many services available on this operating system with multiple types of binaries and libraries available for a variety of potential applications. But in essence, we're only running 1 or 2 or 3 major applications. And so we're wasting 70% of the capability of this OS by only running 1 or 2 applications on it. So what we do now is we take these apps, and instead of running them on an entire operating system, we ask ourselves this question: what does the application need? Let's go back over to the virtual machines. We asked ourselves a question before, which was, what does the virtual operating system need? So if I'm running Windows Server 2019, what does it need? It needs, from the hypervisor, memory, like RAM, random access memory. It needs disk. It needs some type of boot infrastructure. It needs, so I said RAM, storage. It needs storage. It needs a way to transport in and out of that virtual machine. Like, for instance, might need a network, a card, or something like that. So all of this infrastructure hardware is virtualized through the hypervisor and made and given access to this guest OS. Whereas in containers, all we're going to do is find the app. The app needs specific binaries and libraries. So it doesn't need the rest of the operating system. So we just give it the binaries and libraries that are needed from the container engine. And bada boom, you have a container that's working. The most famous open source technology that's being used for developing, packaging, and running applications is Docker. Docker has a lot of different architecture that we don't have a lot of time to go through, but suffice to say the main 3 areas of Docker that we have are the registry. We have the Docker host that actually runs the most important part of Docker, which is the Docker daemon, which is the service that runs in the background, making sure that everything works, especially containers and images. And then on the client, we have Docker builds, pulls, and runs. And all this put together allows us to provide platform as a service in terms of the images that we provide for the containers. So the Docker engine helps manage containers, helps manage networks, helps manage data volumes, helps manage images, all because of the API that works with the Docker daemon and allows the Docker client and many other components to interoperate to provide containers. So microservices or Docker, what are we talking about? So if we have an application, it's monolithic, right? And it's broken into cloud hosted and sub applications. What do we mean by that? So here's a monolithic application. Here we have two apps. There's a business logic and a database layer. So this is often called an N-tier application. So when this application requires a component, let's say one of the business logic components, then there's a call from the app to that component. And if that business logic component needs to access the database layer, then there's a call made from that business logic component to the database layer. Let me give an example. A banking app, and you're transferring $1,000 from savings to checking. And so from the app, you fill in the form, and then you hit the transfer button. Then there's business logic that will check to see if those numbers, if you have $1,000 in your savings account or not, if you have an actual checking account that's valid or not. That business logic will check that. And so then pass that back up to the app, and then the app will create a page that'll say, congratulations, you've transferred the money. So that's a monolithic application. We see a lot of applications that work like that. So a microservices application will have a user interface, and anytime you need a service, like you need a service that will calculate how much money you have in your checking account, well, we get that service called on the fly. We have a service that does something else, it's called on the fly. So these microservices are packaged into the Docker container along with the libraries, the frameworks, the files, and we put that together into a single application. And irrespective of platform, it can be run. So it's actually pretty cool stuff, the microservices architecture. So with Docker, we also have the idea of Docker networking. If we look at the architecture that we see here, we have the underlying network infrastructure, and then we have network drivers, and we have the IPAM driver, all of that. The Docker engine has access to, and then it's going to make those services available to sandbox containers using endpoints. And so we have these containers. They have this is called the container network model, providing the applications portability, really, because you can put these anywhere, irrespective of where it is. It could be Wi-Fi, it could be in one environment or other types of infrastructures, heterogeneously providing access to these containers. So like I was mentioning earlier, orchestration is a big feature. What are some of the items that we need to automate, to orchestrate, to manage? Scaling, provisioning, deployment, configuration, availability, security, health monitoring, load balancing, a resource allocation. So imagine you have many different types of containers, many different images across heterogeneous environments in many locations, but on each of those, there is a configuration change that you need to make. Well, you can use Docker Swarm, OpenShift, or especially Kubernetes to enact that, schedule it, distribute it, make it happen for those individual containers, for those microservices-based applications across multiple clusters and multiple locations in heterogeneous environments. Let's say that you needed to do some provisioning or deprovisioning. So for instance, let's say that because of certain network issues, you needed to deprovision containers from one geographical location and provision containers in another for some purpose. And you needed to automate that. Well, there we have Docker, Swarm, OpenShift, Kubernetes for that. So we can do health monitoring, we can make changes, moves, do scaling, and so on, all across multiple locations, heterogeneous environments. And one of the biggest tools for orchestration, and probably the most used one, would be Kubernetes. Sometimes it's called a K8. Also, it is open source. It's portable. It's extensible. When it says extensible, that means we can take the open source specification and change it to make it fit the environment, the circumstances that I need. It's an orchestration platform made by Google. And so we can do all of the bin packing, moving, all in the many other types of tasks that we saw, scaling and so on, that we saw on the previous slide. You can do all of that with Kubernetes. It does service discovery for your containers. It helps with load balancing. On the storage side of things, it does orchestration. Do you need to do a rollout? Do you need to do a rollback? Oh yeah, Kubernetes can help with that. It's great, self-healing, and it helps with secrets management. What is a secret? A secret is like a hash, a key, a token that provides you access into a resource, but that needs to be kept, well, secret. And so that Kubernetes can help manage that, and even configuration management among all of your workloads dealing with containers. And so Kubernetes actually has a little cluster architecture that circles around the Kube API server. The Kube API server works with the Cloud Controller and Kube Controller managers and really makes a lot use of etcd. And depending on the workloads and so on, we have Kube Scheduler. And so all of this is going to be represented in the environments where you're running Kubernetes as kubelets. We have kubelets, and the kubelets interact with Kubernetes nodes through kube proxies. It's kube everything for Kubernetes. And so what is the difference between Kubernetes and Docker? So let's just look at these 5 points here. Number one, Docker is open source, just like Kubernetes, but it's software that can be installed on any host to do what? Build and deploy and run containerized applications on a single operating system. So multiple containerized applications, single operating system. When Docker is actually installed on multiple hosts, so these are multiple physical devices with different operating systems. So I have Docker installed on Linux over here. I have Docker installed on Windows over there. You can use Kubernetes to manage between these hosts, which is very nice because the modern data center has all kinds of operating systems. So Kubernetes is for orchestration. It does automation, automating the process of creating and managing and updating, scaling, and destroying containers. It does all of that. We can automate it. We can write conditional types of methods for it to run depending on what's going on. It's actually amazing what you can do with Kubernetes. It can be coupled with any containerization technology, like for instance, if you're running RKT or RunC, Docker or Cryo, and there are others that Kubernetes will work with. And both Docker and Kubernetes are based on the microservices architecture and built using the Go programming language. And that way we have small, lightweight binaries. We have YAML files. By the way, whenever you see YA in front of an acronym, it usually means yet another. So yet another markup language, right, for applying specifications and configurations and stacks. So Docker and Kubernetes, a basic understanding, a basic application of the use of Docker is not too difficult. Same with Kubernetes, but at the administration level, there's a lot to learn. So Docker and Kubernetes, containerization for Docker, orchestration for Kubernetes. Now, when you're dealing with containers, you have a lot of challenges with that. Number one is the inflow of vulnerable source code. In an enterprise architecture, it's possible to have code coming in from multiple developers, multiple resources, not knowing which ones have vulnerabilities. Also, because of the sheer number of containers, the sheer number of hosts, you end up in the different heterogeneous applications and so on that you have applied, you have a larger attack surface that needs to be protected, defended. And because these containers reside on top of the Docker engine and they're being managed with Kubernetes, and we have these many different layers, there can be a lack of visibility of what's actually going on in the background. Are we making sure to keep track of all of the possible logs and vulnerabilities, etc., for every layer? Also, compromising secrets. I was talking to you about what secrets were, but there may be one of these layers that doesn't have much visibility where there are compromised secrets. And the enterprise Docker establishment is just running and churning along when an attacker takes the time to check for vulnerabilities, and in a nook, a little corner of the enterprise Docker and Kubernetes architecture are some of that architecture that nobody's been looking at. The attacker finds it and uses the vulnerabilities that they discover against the organization. Over here, DevOps speed. Have you ever met a good developer, a good computer programmer that wasn't busy? I tell you what, they are busy. There are so many projects. There are stacks of projects. Sometimes they're working on simultaneous projects. And over here, you're sorting through all of the layers of your containerized architecture, and you find that there is potential buffer overflow issues on some code, and you submit that ticket to the dev team, but they are so far behind in every project. How quickly are they going to get that patch out? And if they don't get it out quickly enough, who's going to win? Is it going to be the attackers that find that vulnerability? Or is it going to be the dev team that patches it before the attackers get to it? Tell you what, sometimes because of the speed or lack thereof of DevOps, we lose, right? The attackers get there first. The next is noisy neighbor containers. They're always listening to that weird music and banging on the walls. Okay, that's your noisy apartment neighbor. A container neighbor that's noisy doesn't stay in the container. It has the ability, because of issues with the container, and there are lots of reasons why this can happen, and that neighbor can reach out to, especially through attacks, attackers attack it and take advantage of vulnerabilities and get into other containers, right? It's noisy. So that breakout not only to other containers, but they can break out into the host computer system or attack containers through the network architecture. Or these containers are supposed to be sandboxed. They're supposed to be isolated, and bypassing that isolation, again, can cause breakouts. And we hit the nail on the head. We sum it all up with this. In enterprise, containerized, Kubernetes, orchestrated architectures that go from on-premise to multiple clouds, I tell you what, the ecosystem, that's the system of everything working together, can have a lot of complexity. And if you don't have people in your organization that can map and understand that complexity and make sure that every part of that complex, the multi-layered system is protected, then you can get in trouble. So yes, there are some challenges for container security. The next thing we want to look at is some container platforms, some container management platforms. And the first one we've already looked at is Docker, and it has its own management. Docker by itself can containerize applications, secure them, deploy them across multiple cloud environments, and you'll find Docker in most major clouds. There's also ECS, which is Amazon Elastic Container Services. So you get containers from Amazon, we have Azure Container Instances. We have Red Hat OpenShift Container Platform. We have Portainer. We have HP Ezremal, a container platform from HPE. So all kinds of potential container management platforms. And then for Kubernetes, we have Kubernetes itself right there. You can see some of the user interface for an open source container orchestration engine, automates deployment, scaling, etc. But we also have Amazon, Elastic Kubernetes Services, Docker Kubernetes Services, Knative, IBM Cloud Kubernetes Service, Google Cloud Kubernetes Engine. So yeah, irrespective of where you are and what cloud, you can run Kubernetes. All right, now we're going to discuss cloud computing threats. And I'll tell you what, with cloud, everything from the cloud services to the interface, to the storage of data, to the transmission of data, there are quite a lot of risks to think about, vulnerabilities to think about with the cloud. Number one is accountability and data ownership. Who owns the data? Who owns it? So you're using a public cloud, you're hosting your own business services. Whose data is it? So that's number one we want to talk about is a risk with data ownership. User identity federation. So what is user identity federation? Well, the federation is, of course, the Federation of Planets from Star Trek. No, actually not at all. That's what I always think of when I see that term. But what that actually means is I have a single identity. So let's say I log in as Kevin King, and my password is password. Oh man, I should change it eventually, but let's say it's password. And I'm logging in at my local workstation, but using Identity Federation that allows me access to services around the internet and around my organization without having to change my login. Another way to look at Identity Federation is when you are going to a new website, you download the website, and it says log in with your Google account, log in with your Facebook account. That is making use of Identity Federation in the background. We have a single sign-in, SSO, a login, and that is able to be used across multiple locations, infrastructures, and architectures. So if you have multiple user identities for different cloud providers, it's so complex to do so. And so what ends up happening is in order to manage those multiple user identities, we have Identity Federation, and that really helps to manage it better. Now, if you look at the cloud providers, they do a very good job if you take advantage of it in helping with Identity Federation and decomplexifying all the different identities that you might end up be needing in a cloud. We also have regulatory compliance. This is a big issue. If you are running a credit card services, or if you are running, working with a hospital or a clinic or something like that, or if you are an organization that is publicly traded and many other things, you need to take the regulatory compliance that you're doing with your on-premise systems and use those in the cloud. And what if the cloud doesn't give you the transparency you need for the different regulations across different countries that you need? The next is business continuity and resiliency. And so if your business has a major risk and that risk gets realized, you can face major monetary loss, especially if the cloud provider handles the entire thing improperly. And so you need to take your business continuity and resiliency plans and work with the cloud provider to make sure that they are going to be able to implement them as your organization requires. The next one is user privacy and secondary usage of data. So a lot of times there are default share features in social media websites. And in that case, you're on the cloud and you post something and maybe you only want certain people to see it, or you don't realize that everyone's going to see it. And boom, you have shared TMI, too much information. Yet another one is service and data integration. So we have unsecured data in transit. So maybe somebody's logging into a cloud resource using HTTP or some other type of unsecured protocol, and people can intercept it and use it for attack. There's also the fact that in your cloud provider, you're not the only one using that cloud service. There are other tenants. And so if there's poor logical segregation between the tenants, there can be one interfering with the other. Not very good. And then we have number 8, which is incident analysis and forensic support. So let's say that there's been a major intrusion into my network. And my forensics team has a method that they go through to track and understand exactly what happened, get the IOCs of that attack and preserve the evidence using the forensic process. But what we've actually recently started using cloud services. But the storage now is distributed across the cloud. And when I go to do my normal RAM dump or use tools in the cloud that I normally use on premise, I can't get the same level of fidelity, the same breadth of information, because the cloud service provider does not work with my forensic analysis process. And so there could be problems with forensic recovery with your CSP, cloud service provider. We also have infrastructure security. What if your CSP misconfigures a section of the cloud? Sort of an example of that is this happened in around 2016 for a cloud service provider in the Northeast. And there was one of their top tier engineers who works for the provider. And he was running a script. The purpose of this script was to reboot servers for a customer. And he ran the script and it rebooted all of the servers for the entire cloud provider. Can you imagine that? If you are running critical applications in the cloud and all of a sudden your servers reboot, that's insane. It can lead to lawsuits. It can lead to huge losses in terms of money for all of the customers of that cloud service provider. So what ended up happening with, you wonder, okay, I bet you that dude was fired so quickly. But they didn't. They actually didn't fire him. What they did is they asked themselves this question. What kind of company are we that one engineer, any manager, any administrator from one location can run one script and reboot every server? What kind of company are we that can even happen? And so what they did is they used that as a point to review all of their operational procedures, their security, etc. And they kept the engineer. Probably a good engineer, just made a mistake. And I'm glad they kept him because he would have had some trouble getting his next job. So either way, misconfiguration at the service provider can be an issue. Also, non-production environment exposure. So there can be the non-production environment is your test environment. And the test environment might be exposed, allowing unauthorized access through that environment, information disclosure, etc. That non-production environment needs to be kept away from exposure to the rest of the world. So there are threats to the cloud because of all these issues that we have in the cloud. There are a huge number of threats. We'll just look at these and stop at a couple of them and talk about them, a few of them. Data loss or breach. This is that you can lose your data because of the way the cloud interface and the cloud resources are configured. Abuse and nefarious use of cloud services. You have an administrator that is using your cloud resources to mine cryptocurrency. Something like that. It's an abuse, right? Or selling storage to someone else and creating accounts for outside users on your cloud. I mean, that's possible. It's an abuse. Insecure interfaces and APIs. You test the API, you find that it allows people to hack into the service. Insufficient due diligence. Your CSP hasn't gone through and checked everything they should, and maybe your organization hasn't. Shared technology issues, because like we said, you're sharing this with some cases millions, and other cases billions of others at the same time. And if you're all sharing the same technology, there could be a problem, and you're all potentially affected. And then unknown risk. You don't know every technology that your provider is using. There could be risks that you cannot foresee in cloud computing. Unsynchronized system clocks. So you're running in the cloud, you're using something like Azure Active Directory, and you have on-premise computer systems, and none of them will log into Active Directory because your cloud clocks are different than your on-premise clocks. Inadequate planning and design, conflicts between client hardening procedures in your cloud environment. You try to run the same procedures in the cloud, and there are things missing. A loss of operational security logs. Perhaps they truncate logs automatically after a certain amount, and you can't get them after that, and so therefore you lose visibility to part of those logs. Malicious insiders. That is the same potentially as abuse and nefarious use of cloud services. So somebody on the inside of your organization is doing something they shouldn't be doing with cloud services, or illegal access to cloud systems. The malicious insider, the one who is abusing the services, creates accounts, login accounts for her friends. And so she gives those out, and they log in, and they use those to store their videos and movies and Amazon S3 buckets or whatever. They shouldn't be doing that. Or maybe they're hacker friends, and they're using the cloud to store items that are illegal, photos that are illegal, things like that. There are many different ways that the cloud can be used. Some of it's illegal. Loss of business reputation due to co-tenant activities. You're on a cloud service provider that provides that has been the major provider for the crime boss of the Northern Hemisphere. And once it found out that most cloud services are used by the crime boss of the Northern Hemisphere, and you're also using the same cloud provider, maybe the new services will arrive at your door. Hey, XYZ Corp, do you realize that you are on the same cloud as the crime boss of the Northern Hemisphere, right? You can get a bad rep because of someone else who's using the same service. There can be privileged escalation, natural disasters. There are always hurricanes hitting in the Gulf, hitting Florida. There are earthquakes in California. There are faults up in Washington, and there are volcanoes all over the planet. And if there is a cloud service provider that happens to fall prey to one of these natural disasters, hey, where's your data? I hope it was on one of the other data centers. Hardware failure in the cloud, supply chain failure in the cloud, traffic, because you're not sure how that traffic is being monitored and managed in the cloud, and so it could be perhaps modified. Isolation failure, someone breaks through your cloud services or their services and breaks into your services. Isolation failure. What if you're using XYZ cloud provider and that cloud provider gets bought by PDQ cloud provider? What happens then? It's been acquired, and the answer is who knows? There can be management interface compromise for the software that you manage the cloud. There can be network management failure either at the CSP or even in your organization. There can be authentication attacks because maybe when your organization set up the authentication, they used the lowest possible denominator, and now it's being attacked. There could be VM level attacks where either from within the CSP or from within your organization, VMs are being attacked. There can be lock-in. Lock-in. Lock-in is when you are using a CSP, a cloud service provider, and let's say that you have your entire organizational architecture, everything, all your servers, all your workstations, all your, let's say your services, like for instance, web services, your databases, your identity services, everything is in the cloud, and it's actually going pretty well. Your organization is able to run lean, and then something bad happens around you, and you need to cut the amount that you're paying out as an organization every month, and you have this cloud bill. And if you could just move your services from PDQ cloud provider to XYZ cloud provider, you might be able to save $1,000 a month, or maybe even a week or a day, depending on what it is, right? It could be a lot of money. But how do I move all of those complicated services that I currently have in that cloud provider to another cloud provider? It is, in some cases, almost impossible. I will say this, that as time goes on, there are more and more tools to help with this, but you could be locked in. There could be contractual lock-ins where you can't get out of the contract, or for other reasons, technological lock-ins. The opposite of lock-in is when you're kicked out and you can't get into the cloud, but that's a whole nother story. We have also licensing issues, loss of governance. Oh, by the way, this happened with Zoom. In early 2020, when everybody started using Zoom, some people realized that Zoom was moving a large amount of its data through Chinese servers. And so since there is no guarantee of anonymity if they're in Chinese servers, essentially you lose governance when that data goes into China. A lot of people figured that out. And so finally Zoom separated those networks and has Zoom for China and Zoom for the rest of the world. A loss of encryption keys is a possibility depending on the types of intrusions or circumstances in the cloud. Risks of change of jurisdiction. I have information in the cloud that originated in the United States but stored in Europe, and there's an investigation. That data, where's the jurisdiction for that, right? Malicious probes or scans from the cloud or into the cloud provider, and I don't even have access to that. Theft of computer equipment. Somebody breaks into the cloud service provider, steals 17 servers, and guess what? My data is on those 17 servers. It might be backed up, but yet, and I can still access it, but someone has a copy of it. I mean, wow. What about the cloud service terminates or fails, and they terminate me, right? Kick me out of my cloud service. This is all under the auspices. I guess you can put when somebody is deplatformed in number 32 also. You could lose your cloud services. Subpoenas or e-discovery. There could be a subpoena that somehow now encompasses your data, your information in the cloud. Improper handling of data and disposal. So your cloud service provider says, all right, well, we're finished with that server. Let's go ahead and sell it on eBay. And it has your information on it because it was improperly disposed of. A loss or modification of your backup data. So when you go to restore it, it's either not there, or half of it's there, or it's been changed. That's not very good. We also have compliance risks. Perhaps you signed up with the cloud service provider without doing your research, and it turns out they can't handle your compliance issues. You could have economic denial of sustainability. And again, this goes back into the economics of the cloud. We've been talking about that for a while. The security architecture can be messed up. You can have accounts hijacked. So there are lots of threats, and those are 39. And every time I see this list, it grows. And so there's going to be more. So you have to be careful and methodical when planning what you're going to do in the cloud. So one of the cloud attacks that we need to talk about is a side channel attack. Whenever you hear the term side channel attack, that's when you're not directly attacking the service itself. You're going around that and attacking something else that'll give you access to that information. Or sometimes you can call it a cross-guest VM breach. And so what we do in this case is we have an attacker here, a user who's making use of virtual machines, and you have an attacker that's has stolen the credentials of that user, impersonating that user because of stolen cryptographic keys or plain text secrets, stuff like that. So a type of side channel attack can happen when this attacker over here sets up their own VM. And so they're running a virtual machine on the same physical host that the user is. And because they're on the same processor or whatever, they can check that processor cache and use various techniques to steal information from that and use it against it. Because of co-residencies, you can have side channel attack vulnerabilities: a timing attack, data reeminence attack, acoustic cryptanalysis. This is kind of crazy here, where you set up something that listens to what the server is doing, what the acoustic vibrations of that server are, from the fans to the boards in the server, et cetera. There are power monitoring attacks where you look at when power is peaked. So like, for instance, if one of the VMs in that data center or in that particular host does a particular cryptographic calculation, it spikes power. You can look at differential fault analysis and analyze any faults, or even create faults and check out the differences between the responses from those faults. So there are lots of attacks that can happen between guests because they're on the same hardware, and you can analyze that, do some cryptanalysis, some other types of analysis, and eventually crack into another VM. Also, we have cloud wrapping. A cloud wrapping attack involves translating SOAP. Now, SOAP is an XML-like communication technology that's used between portions of applications. So in this case, we have a request that's being sent to a web server. It's in the cloud. And then SOAP has a message header, and then has a body. And what happens, the attacker intercepts that SOAP message, and then they duplicate that original document, copy the header, modify the body of that, send it back, and then they're able to get various types of information from the application and do other types of attacks because of the wrapping attack. Another one is man in the cloud, very similar to man in the middle, man in the browser. In this case, it's man in the cloud. It's a type of man in the middle attack. And so what's going to happen is we're going to start with the attacker tricking their target into installing malicious code. How do you do that? Well, let's say you leave a flash drive in the parking lot. It's 256 gigs. It's brand new. It's in the package. It's never been opened. So they pick it up and they plug it into the computer. Or you get an email message that says, click here to win $1 million. Okay, click. Either way, now that the malicious code is on there, and it plants the attacker's synchronization token on that person's computer, on their disk drive. And so they steal that synchronization token, use that to gain access to their files in the cloud. But guess what? Later, they're going to restore the token with the original synchronized token and return it to the original state. So they can go in and out of that cloud using that stolen token and then restoring it. Very interesting stuff. Next, we have cloud hopper attacks. And so this is triggered at the managed service provider's location. So here we have the MSP. They're providing us with access to services. They control and work with users from many different locations. So we have organization A, organization B, organization C, D. There's organization E right there, and they're the victim. So what's going to happen is this attacker, and the way you can tell that this is an attacker is because of the hoodie. Well, maybe the sunglasses, but yeah, both of those really help. So what they're going to do is they're going to send a spear phishing email that has custom made. So with spear phishing, you're targeting specific individuals. So you know exactly how to make this malware. And so you compromise the staff at the cloud service provider, and you're able to use this to get confidential information and further compromise the cloud services. Another one is called cryptojacking, cloud cryptojacking. And this is where we unauthorizedly, made that word up just now, unauthorizedly use the victim's computer. What are we doing? We are doing crypto mining. So if I have enough computers that are mining Bitcoin or Dogecoin or Ethereum for me, it can be highly lucrative. And so what happens is the attacker can use many different vectors. Like, for instance, there could be a misconfiguration in the cloud itself. There could be a misconfiguration in the way the cloud is implemented locally. There could be websites that are compromised. There can be client-side or server-side vulnerabilities. But either way, the cloud service is now embedded with a crypto mining script, and over time it begins mining and collecting those little pieces of cryptocurrency. The next type of attack is a cloud-borne attack. A cloud-borne attack is an attack that is actually at the bare metal. When we use the term bare metal, we're talking about the actual hardware of the host. What the attacker does is they attack firmware. So there's a backdoor that they inject, then they can exfiltrate customer data through that backdoor. And so they can bypass all the security mechanisms of that server and do almost whatever they want. And so when you think of cloud-borne attacks, that is the bare metal cloud server, the host firmware that's usually attacked to make that happen. Another type of attack can occur using a very interesting tool. This tool is called Lazy 3, Lazys3. You can call it Lazy 3. The S3 is for S3 buckets. So that could be like an E or something like that. So what this is a Ruby tool. In fact, if you start the tool, you can see Ruby, Lazy Ruby HackerOne, and you get it started. So what does it do? It's there to brute force S3 buckets. Remember, we talked about S3 buckets. They are extremely versatile storage. It's an extremely versatile storage architecture for storing lots of information, files, folders, objects through web APIs. And so what they want to do with brute forcing this with Lazy's is they're going to find the bucket's location and name, and then identify vulnerabilities. Another cloud attack tool is Nimbostratus. Nimbostratus is like a cloud layer, right? These are both clouds in the atmosphere. What is the purpose of Nimbostratus? It's to fingerprint and exploit Amazon cloud architectures. Get that IAM, that identity role, extract credentials, metadata, usernames, location, information about businesses and details and so on like that. Nimbostratus does that. But there are other tools that can be used to attack the cloud, including S3 Scanner, CCCat, which is a cloud container attack tool, Paku and Dumpster Diver, and so many others. And this is just a partial list. All right, so now we're going to look at how you can better defend your cloud with countermeasures. Let's put up the countermeasures. So what are some of the countermeasures that we can use to defend the cloud? Number one is enforce data protection. So when we look at what does that mean? To me, I'm translating that as ubiquitous encryption and ubiquitous identity management. So we can protect data through identity management and encryption, making sure we're backing it up, making sure that we have good data retention and rotation mechanisms. Also, read your SLA. What's an SLA? An SLA is a service level agreement. And you need to know what that says for patching, vulnerability, remediation. You need to know what the SLA says for not just those, but for every part of your cloud service with that cloud service provider. Also, make sure that your cloud service provider is regularly undergoing an AI, CPA, SAS 70 Type 2 audit. So just check with the documentation on that cloud service provider. Check that. Prohibit user credential sharing. So I give the same advice when I'm dealing with, like, for instance, Cisco infrastructure or network infrastructure. Same thing here. You don't want to have like one or two logins and share those things. No, we want to make sure applications, services, and users all have separate credentials. Also, strong authentication, authorization, and accounting. That's AAA. That's part of identity, like I was talking about before. Strong key generation, storage and management. And most cloud service providers have very strong recommendations for this. You may want to follow them. But there's more here. There's also making sure that the cloud undergoes regular security checks and updates. So just like you're going to do in your infrastructure network, you want to always be checking that cloud to make sure that it is ready for attacks. We also want to make sure that the cloud service provider has physical security 24/7, 365. And if you've ever looked at a cloud service provider, you can go to YouTube, for instance, or you can go to a regular Google or DuckDuckGo search and type in a cloud service provider, like, for instance, Amazon, AWS, physical security. Type that in, and either in YouTube or in a regular web search, you'll find that it's amazing. I mean, they are so physically secure. There's only like one way to get in, and you have to meet a security guard. And if you don't already have an appointment, you can't get in there if you don't have the appropriate physical credentials. And one place I went, not only did I have to give them have an appointment, and I had equipment that I regularly visited in this CSP, but I can't just walk up and go into the provider. And once I give them 2 forms of ID and get into it using a code, etc., in order to get into the physical area where the server surfaces are, there's like a bone geometry scan on your hand, and there are all kinds of cameras, and some places have almost like airport level security. There's a lot of security that you find at these cloud service providers. Look it up one of these days. You'll find it to be very interesting, I think. Also, we want to make sure that we, in terms of security standards for installation and configuration at the CSP and on-premise, we want to enforce those standards. We want to make sure that memory storage and network access is isolated. Again, check with your CSP. Find out what their methodology is for isolation. And better yet, get anecdotal reports from other people who make use of those services and find out if how many isolation failures have been reported for your CSP. Implement a baseline security breach notification process. This is going to be part of your incident handling and response. Analyze API dependency chain software modules, and making sure that you have secure APIs on premise, in the cloud, as a cloud service provider, is one of the most important tasks for any organization that deals with applications on a regular basis. There are many methods that you can use to test APIs, including fuzzing and other methods, to make sure they're secure. Right? So very important to do all of this to make sure that your cloud connections are going to be secure. Now, against specific types of attacks, like for instance, a side channel attack, you're going to need virtual firewalls in the cloud to stop one instance from being able to access another instance. We're going to need a random encryption and decryption. We're going to need lockdown of OS images and instances so that there are no vectors that an attacker might follow to attack another instance in the cloud. For wrapping attacks, what we need to do is validate that XML schema to use that validation to detect SOAP messages. Apply unauthenticated encryption in XML, in that XML encryption specification. So we want to make it so that it is impossible for somebody to take advantage of those SOAP messages. For man in the cloud attacks, one of the first things we need to do is have good email security and training our users so that somebody doesn't click on a link and get socially engineered. We need to harden our policies for token expiration so they don't expire so quickly. And also CASB, this Cloud Access Security Border. Implement a Cloud Access Security Border. Why? Because at that cloud border, we want to monitor traffic going to and from the cloud. But what about cloud hopper attacks? Multi-factor authentication. Another thing that we talk about quite a lot is identity management, right? And MFA is extremely important. We want to make sure that we have mutual coordination between the customers and CSP in case you get incidents and activities that seem abnormal. We want to make sure that customers are aware of the cloud service policies. These are very helpful in a cloud hopper. But what about crypto jacking? And one of the first things you want to do is have strong pass phrases. Have a policy that makes that important for the at the cloud service provider level and at the mainly this is going to be at the customer level that's making use of the cloud services. Always preserve 3 different copies of the data in different places and 1 copy off-site. All right, so we want to air gap that information. Next, we want to implement coin blocker URL and IP blacklist black holing in the firewall. Blacklist is a list of IP addresses that are known bad. We don't want them to be able to be used anywhere near our network. Black holing is when a malicious communication tries to make contact with our network. It just gets dropped. And now normally when communication doesn't make it to where it's going, that communication sends back, like for instance, an ICMP message to give the person initiating the communication some type of indication as to what happened, why the communication didn't make it. So I don't care if it's ICMP, I don't care if it's some other type of reporting. With black holding, nothing comes back. And that's really good because then the attacker can't use the feedback information for further attacks. Another one we have is cloud-borne attacks. And to protect against cloud-borne attacks, firmware needs to be on the update schedule. Not just your operating system, not just your applications, but the firmware also. So sanitize server firmware before it's assigned to new customers because it may contain information or and cause more attacks. So these are some of the specific attack countermeasures that we can do. But I want you to know that there are tools that can help with cloud security. A Qualys Cloud Platform, a very nice end-to-end security tool to help you to strengthen your cloud security posture. We also have Cloud Passage Halo, another extremely good one. Cypher Cloud, Prisma Cloud, McAfee Vision Cloud, and so many others. And so there's a lot that you can do to secure your cloud. There's a lot that you can do to secure your containers. There's a lot you can do to secure your container automation and orchestration with Kubernetes. And so there's a lot of technology layer upon layer upon layer when you're dealing with the cloud, when you're dealing with containerization, when you're dealing with the specialized attacks that can happen against the cloud infrastructure. We need to be vigilant and we need to map it out carefully and have well thought out and executed policies. So this brings us to the end of the cloud section. In the next section, we're going to spend a little time talking about an exciting topic, and that topic is pen testing. So that brings us to the end of this module, and we'll see you in the next module and in the labs.